What's up, guys? As you know, I'm moving from room A204 to room D212. And one of the questions I was asked was, do you want to bring the big teacher desk? And I said, no, I don't really like the big, old, heavy, wooden teacher desk. I like this nice light table I have here with a computer on it. But the stuff in the desk, the stuff in the desk drawers, I probably will bring over, the pens, the scissors, whatever. I'm just going to organize it in a different way. And the thing is, every way has pros and cons. If I put the stuff on a shelf, then it's all out in the open and you can see what you have and you can grab whatever you need. But I don't really like a shelf. I think it's distracting to have everything out in the open. If there's something I only need once a year, I don't want to see it every day. Plus, the stuff can get dusty, it can get knocked over. Maybe instead I'll put it in a cabinet. It's out of the way, but the problem with the cabinet is I'll definitely forget. And if somebody says, can I have a Band-Aid, I'll open 5 before I find the right one. Now, that doesn't matter. They don't care. If somebody says, can I have a Band-Aid, and I give them a Band-Aid, they don't care if I got it out of a drawer or a desk drawer or a cabinet or a shelf or one of those fancy little plastic bins with the label on it. The customer, the user, doesn't care, right? And that's the same thing with our data in computer science, okay? You put your stuff in the memory somewhere, and then you bring it out when you need it, but it doesn't really matter. And it's a lot of preference sometimes. If you think you want to write the code a certain way, and it's easier to read, maybe it's easier to change, maybe it's easier to explain. That's often what we're going to run into. Yeah, sometimes one data structure will be so much faster or take so much less memory that it's really, obligatory to use it. But in this case, we're going to see that a lot of them are pretty similar. So let me show you what I'm talking about. I thought of an example, which is this. At the end of last quarter, you guys were making games, tic-tac-toe, hangman, whatever. And some people were doing card games, war. When we did that, you have a card with some data. It's got the suit, the rank, the name, and you have to store that somehow. And we never really found one that we liked, right? One example I showed was using a tuple. And a tuple is when you just put some stuff with some commas in order, whatever order you want, and then it gets that index, 0, 1, 2, etc. Waiting for the webcam to come back. And then you reference it with that index. So let's say we're going to make a deck of cards with rank and suit. I call it R and S in this. And then if ever I want to get one of those attributes, I need to say 0 or 1, and that works really fast. It doesn't take much time or memory, and if I run it, it works. But I hate that when I'm looking at the code, because when I see card 1 0 or card 1 1 or card 1 the whole thing, I don't really know what that means. It's like you need an instruction manual to use this very simple core thing that's the whole program is about. And then I made one function where you send the tuple to this and it'll send back a pretty printable version. That's terrible, right? Even though it works, okay? So I wanted to do something better, or at least something different. Maybe other things will have drawbacks, but they won't be the same drawbacks. Just like putting stuff in a shelf versus a cabinet versus a drawer or whatever, okay? So I thought, let's go back and let's do something even more basic, a string. You can put your card data in a string. And when you run that, you get exactly the same output, okay? When I run this game, I know it has to reload the webcam on the dang Loom app every time. You get the same stuff when you run this, and it's a simple program. It's like 40 lines and half of them are blank. But instead of putting them in a tuple, I put them in a string where it's each one is 12 Queen of Hearts or something. So the first 2 characters are the number, the value, and then the rest of them are the name. So that if you need the value, you get the first couple characters, and if you need the name, you get the rest. And that still works, but it's still ugly, right? You still have to do the index thing, and now it's got slicing involved. And now sometimes I put strip on there because what if it's got a blank? Like, that still sucks if you're reading the code. Not now because it's a tiny program, but if it got bigger, if we were making poker or Yahtzee or a more complicated game, it would definitely suck. And I would hate this in a bigger scenario. So what if we did something else? There are never lack of possibilities. Okay, you always have infinite possibilities of how to do things in computer science. One thing when it comes to the tuple is that we're not alone. Everybody had this issue, which is that if you have a thing with some attributes, you don't want to call them 0, 1, and 2. You want to call them, first name, last name, whatever. And so people came up with this idea a while ago. People came up with this idea of the named tuple, where each thing actually has a name instead of just a number. And I wanted to show that. You have to import it, just like we imported random, okay? It's from a module called collections, which is kind of old. People don't use that much anymore. But the idea is you say, okay, there's a named tuple, and it's got these attributes. And I made 4 because sometimes you want the name or the full name or just the suit or whatever. And then this line is really ugly. If I was going to make something bigger, I would, describe it a little more and give it full names. But just to squish it all in, I made this. And then, wonderfully, you can reference attributes by actually saying what they are, like card1.suit, card1.rankValue, card1.full name. And that's so much better and so much prettier. It's like English instead of some weird computery thing, right? So people use this, and there are newer versions or newer things that do the same process. There's something called adders, which stands for attributes, that a lot of people used for a while, and now there's an even newer one called data classes, which a lot of people like. The point is not, hey, you should use named tuples. The point is just like, hey, there are a bunch of ways that people have come up with to organize your data, and it's exactly the same in the output. The user won't know how we're doing it behind the scenes. Just like when you ask me for a Band-Aid and I give you a Band-Aid, you don't care. You might not even notice if I have it in a little plastic bin or a little envelope in a drawer or whatever. Okay? But that's not the only way. What if we wanted to use something else? The next thing in our code HS is something called dictionaries. And I don't use them very much, but maybe I should because they really are nice. A dictionary is something where instead of putting items in a sequence with like 0, 1, 2, and everything is like a little table with a number corresponding to your next guy. It's like a dictionary where you look up a word and you get a definition. You look up a word and you get a definition, and they call that key. So it'd be like the key is the thing that points to the answer. And then when you make a dictionary, you say, okay, I'm giving this names very similar to the attributes I did in my name tuple, where I'm calling it rank name or suit or whatever. And then later you can reference it pretty much the same way with brackets instead of a dot, but it's the same idea. And just like the others, it's the exact same output, and the user will probably never know which is which. But it's kind of nice. Like I said, I don't use dictionaries much, but I probably should because they are really good and efficient. They don't take up much memory or time or any of that stuff. But the one we're going to get to eventually, and the one that is where a lot of the real power comes from when you want to do something big, is something called the class, okay? In Python, you've heard of types, like integer, string, whatever. And in Python, not in every language, but in Python, class and type are referring to exactly the same thing, okay? So you can make your own type if integer doesn't quite work for you, or if lists don't quite work for you, or whatever. You can make your own type and then just define what it is. So here's I made two ways of doing a class. Let me show one first. I'll show the other. This is getting into a term you may have heard, maybe in a YouTube title or something. There's this term called object-oriented programming, which sounds scary, but it's just this idea of like, we're going to make an object and it's going to handle all of its business sort of inside its own walls. And then if any other part of the code wants to get involved in that, it'll send a message to the object. So when you make a class, you just say the word class, which is pretty easy to remember. And then you'll give it what they call methods, which are like functions, but they're attached to that guy. So the first method is the init, the initialization, which is going to create it. And we gave it some little variables, aka properties, aka attributes. There are a couple different names for these things. And then whenever any other part of the code wants to access that, it doesn't do it directly. It's going to send a message with these functions or methods we call getters, where it's going to say, hey, excuse me, sir, what's your suit? What's your rank? What's your full name? And then it's going to return that, okay? It's sort of like keeping it separate and polite. Like instead of reaching into their pocket to grab the wallet and see what's on their ID, you ask them, oh, hey, what's your birthday or whatever. That is very reasonable, and we're going to use this sort of object-oriented programming when we do graphical stuff. If you have Pong and you've got the little ball bouncing around, it's going to send a message to the paddle and say, hey, am I touching you? Am I touching you? Every frame, and one day it's going to get back a yes, and then it's going to say, oh, I need to change direction and bounce off. So that's a very good thing to get your mind around. When we use it in the code, we can use these getter methods like get rank value or get full name, and they're nice and descriptive. They're not short. You got to type a tiny bit more than just dot whatever, but they're nice and descriptive. And when you run it, guess what? It's exactly the same as the other programs. No one would ever know what you're doing behind the scenes, or no one would ever care. Let me show you one more, and it's using a class in a slightly different way, which I kind of like depending on the situation. So when we did this class, I had this init method with the 2 underscores, and that's called a dunder, which stands for double under. And the thing about those methods is that you never actually mention them by name. So like the get name or get suit or whatever, you were saying dot that, but the dunders are sort of built in behind the scenes things. When you run it and make one, then it automatically does the init. And there are lots of other dunders that you can make. The example I used here was less than, greater than, equal, so that the beauty of this, I couldn't even say it because I'm so overwhelmed by how great it is that you don't even have to do anything. Remember the other examples we had to say bracket index or bracket dictionary key or dot attribute or dot getter method. For once you define the less than and greater than stuff, you can just say if card 1 is greater than card 2, and then it'll go into the right attribute behind the scenes, and you don't even have to worry about it. That's beautiful. In the code, you can read that, no problem. You can write that, no problem. You don't have to look up what it is, nothing. It's wonderful. And then when you want to print it, you can just say it, because I defined the str dunder, which is like, what do we need when we're going to print this? Which is like, hey, we're going to take the rank name and the of and the suit. And so when I run this, it has exactly the same output. No one would ever know the difference. But IMO, this code is so nice to read and write. This card 1 is greater than card 2. We don't need to know what the names of the attributes are, any of that stuff. You can just print it and just say, hey, print the card, and the card will take care of the issue. That's what classes are good for, is it like you can make a type that knows what it's all about and knows what to do, and then it can handle its business. And you can just say, hey, what's your name? What are you doing? How do we print you? Are you graded? And it'll do it. Now, that takes a lot of work, and this is a little chunk of code that makes this slightly longer than the other ones, but who cares? The point of all this is I'm not saying you have to learn classes today. I'm not saying you have to use name tuples today or ever, really. But they're all the same. They're all just data moving around. If you ask me for some scissors and I get it out of the cabinet, or I get it out of the shelf, or I get it out of the thing over here, you don't really care. You got the result. And when your program gets the result, that's the important thing. If you have some stuff behind the scenes that is different from your neighbor, that might be okay. One of them might be slightly a couple nanoseconds faster, or one of them might take a little bit less memory. But most of the time, with the stuff we're doing, we're not being that ruthless, and it's about how can you read it, how can you write it, how can you share it in a way that people look at the code and they're like, oh, dang, I know what that means, rather than what the heck is this? So, like, card bracket 0, what does that mean? I don't know about that. So what we're going to get into this quarter is making the stuff organized, labeled, smooth. Nice. And then when you get to doing graphical stuff, assume that's the fourth quarter, but who knows how we'll speed up or slow down, then it can be understandable, and you can just say, like, I don't know, ball.move in your Pong, and the ball will move. And you won't have to, like, calculate new stuff every time. You'll just define it in the ball, and it'll know how to bounce. It'll know how to do stuff on its own. That's the beauty of all this. Thanks.